Launching NASA's research tests was like the beginning of an amazing journey into space. It showed that we can keep tabs on Earth, as well as everything in our nearby planetary group and beyond. Even after 46 years, these amazing space instruments continue to provide scientists with new and shocking information about space. Although their memory is 3 million times smaller than the memory of our mobile phones and the speed is 1,000 times slower than our fastest 5G network connection, these incredible tests still lead to space exploration. Now Explorer 1 has made an incredible discovery in interstellar space, challenging everything we thought we knew about the universe. It found something so rare that scientists are left scratching their heads. But what exactly did it find, and how will it redefine our understanding of the universe? One day, on September 5, 1977, something amazing happened in a place called Cape Canaveral, Florida. Explorer 1 began its journey into space on a powerful rocket called Titan II. Only 15 days later, on the 20th from August 1977, Explorer 2 joined and began its adventure in the universe. Their main task was to study the large gas planets of our planetary group, such as Jupiter and Saturn, and their surrounding moons. But guess what? These space travelers went much further. They ventured into our vast solar system, breaking many records on their incredibly long journey. They traveled farther than any other spacecraft ever, and they went farther from Earth than any human before. They even went to a place called interstellar space, which is like going to a completely different part of our system that no one has explored before. These space pioneers, Explorer 1 and Explorer 2, are now more than 12 billion miles away. However, they amaze scientists with the wonders they find there. They recently discovered something so unexpected that no one saw it coming. Research double tests have been doing great things for a long time. When they looked at the moons of Jupiter and Saturn, they completely amazed scientists. People thought these moons were dim and full of holes like ours, but apparently not. They're buzzing with activity. Explorer 2 was the first of the twins to fly past Uranus in 1986, and just 3 years later it zoomed past Neptune. But here's the interesting part. It's the only rocket to ever do that. As these rockets continue their amazing journey, NASA is doing a few tricks to make sure they last. They turned off some things they didn't need, like plug-ins and heaters, to save energy. So these rockets could work at least until 2030. For the scientists and engineers involved in this incredible adventure from the beginning, it is a mixture of happy and sad emotions. They worked hard, and now, when they thought the exploration missions were almost over, an amazing discovery appeared from space. The data sent by Explorer 1 and its twin shuttles has become the mother of scientists. They led to many discoveries and made people fascinated with space. These are two shuttles built with extra care, as stable platforms, to be able to take clear images and collect data while zooming through space. Even before reaching the outer planets, their photos knocked the socks off scientists. Explorer 1 began sending images of Jupiter, even though it was still far from the planet. Staff at NASA's Jet Propulsion Laboratory were excited to see the first images of Jupiter's swirling clouds and the famous Great Red Spot. But the defining moment came when researchers discovered something amazing on Jupiter's moon Io. This moon, which is certainly larger than Earth's moon, turned out to be the most active volcano in the entire group of planets near us. Explorer 1's instruments picked up strange signals from Io, and the pictures they took showed huge volcanic eruptions and things flying into space. One of Io's volcanoes, called Pele, erupted massively, even taller than Mount Everest, and covered an area almost the size of France. In total, scientists took more than 33,000 images of Jupiter and its moons, showing how magnificent Jupiter and all the different scenes of its moon are. Another big surprise was discovering that Jupiter has rings, although they are not very bright. This discovery made Jupiter even more interesting. In addition, Explorer 2 discovered that Europa, one of Jupiter's 53 moons, has an icy crust more than 60 miles thick. These revelations made scientists rethink what they thought about those distant objects in space and made them wonder if icy moons like Europa could be habitable. When the explorers left Jupiter, they were pushed by the planet's gravity, which acted as a powerful shock and sent them to Saturn. This shot was especially important because it helped them break free from the sun and continue their journey into space. Explorer 1 and Explorer 2 then went their separate ways to the new locations. Explorer 1 approached Saturn's moon Titan, which is surrounded by a type of orange haze. Intrigued by Titan's mysteries, scientists studied its complex chemistry. Explorer 1 then turned away from the other planets and began to go outside our solar system. On the other hand, Explorer 2 also had some great adventures. In 1986, it flew past and discovered 10 new moons, increasing the total. 3 years later, it reached Neptune and showed us amazing things about this distant ice giant. Explorer 2 measured wind speeds of up to 1,000 miles per hour on Neptune, the fastest ever recorded on a planet in our solar system. As the shuttle approached Neptune, only 2,900 miles away, it gave us new and wonderful insights into this distant world. Neptune's largest moon, Triton, turned out to be one of the coldest places in our group of planets, with temperatures falling below -391 degrees Fahrenheit. Triton also had these cool ice volcanoes that spewed nitrogen and icy stuff into the air. These revelations made us realize how unique and fascinating the planets and moons of our solar system can be, even the most distant ones. Imagine a story about a space adventure, and one person who was very influential in promoting it was the famous astronomer Carl Sagan. He was part of the imaging team for the Explorer mission and wanted to take one last set of images before turning off the cameras. These photos would be like a special gift to everyone on Earth, a last look at our home from the far reaches of space. Sagan did not give up, and it paid off. On Valentine's Day 1990, Explorer 1 turned its camera back toward the interplanetary group and took 60 images. The most famous image, known as the pale blue spot, was taken from a distance of 3.8 billion miles, making it the most distant image ever taken of our planet. In the photo, the Earth appears small, like a pale blue, in the vast space around it. Even after 40 years, these shuttles are still out there sending us valuable information from the far reaches of space. Now let's talk about something a little outdated. The research tests used the old Clinius system. Yes, you heard that right. 8-track tapes were a big thing in the 70s, and these tests are still rocking them.
It just goes to show how smart the people who designed it were to make sure those old tapes still did the job. But why 8-track tapes, you might ask? Well, this is a story worth listening to. In the early days of space exploration, today's digital recording was still in its infancy, so they needed something durable and reliable to store important information, and these 8 tracks proved to be the perfect choice. Even more interesting, the information on these tapes is not just ordinary music. It is valuable scientific information about the planets, moons, and interstellar space. Yes, these tapes contain the answers to some of the greatest mysteries known to man. Now consider this. The Explorer shuttles are exposed to crazy things like extremely hot and cold temperatures, space radiation, and the vacuum of space. But of course, these old travelers are still thriving. It's like you sent your grandparents on an adventure to Antarctica and they not only survived, but thrived. The Explorer missions had this amazing move called gravity assist. Think of it this way. Explorer 1 and Explorer 2, two hardy space pioneers, were on a grand mission to explore the far reaches of our group of planets. To move to these remote locations and gather valuable information, they needed some help, something besides just their engines. This is where gravity supports come in, and it's a kind of space dance. Instead of just using their engines, these rockets do this cold celestial dance with some of the major planets in the planetary group. They use the powerful attraction of these giants to propel themselves forward, saving fuel and gaining the necessary speed to go to many different places. Gravity assist, also known as gravity crawlers, consists of picking up the speed of the planet as the shuttle passes by. Imagine Explorer 1 heading for Jupiter, a massive gas giant with a gravitational pull proportional to its size. The research center has ensured that Explorer 1 will pass Jupiter at the perfect point in speed. Jupiter's gravity pulled space and made it go faster, like the force of space. But here's the interesting part. There is art in this movement. If Explorer 1 had missed Jupiter, it could have been a space disaster, sending space hardware far from base. Fortunately, NASA experts managed to do it, and the priceless celestial dance with the planets was a great success. The degree of precision required is high, but guess what? The intelligent scientists and designers who designed this magnificent celestial dance made sense. Using Jupiter's massive gravity, Explorer 1 gained the necessary speed to traverse the planetary group and even reach interstellar space. It's like a beautiful space ballet where gravity was the star point. One of the unsung heroes of the exploration missions is the Deep Space Network, DSN. Think of DSN as a sophisticated space hotline that ensures scientists can talk about distant tests. Located in California, Spain, and Australia, this network of radio antennas is critical for the success of the Explorer missions. DSN helps distant spacecraft send data back to Earth by picking up weak signals and turning them into valuable information that scientists can use. That's no small feat. Probe signals are as faint as a whisper a million miles away. DSN's incredible antennas tune in and make sure nothing gets lost in the vast space between us and the explorers. DSN doesn't just accept data either. It also sends orders to the scientists, telling them what to do next. This two-way conversation is critical to changing mission plans and continuing the explorer's journey. It's like a special walkie-talkie to talk to a spacecraft billions of miles away.